Hello, welcome to GP Podcast. In the world of AI, there's always been this fundamental trade-off, speed for power. To get a smarter model, you just had to accept a slower one. But then, in early 2025, one company quietly shattered that rule, leaving everyone scrambling to ask, how on earth did they do it?
So, that company was DeepSeek, and their secret weapon was a revolutionary technique called multi-head latent attention. By completely rethinking how an AI model remembers information, they were able to shrink a critical memory bottleneck by a staggering 57 times.
And look, this massive memory saving wasn't just for show. It had a direct, and I mean direct, impact on speed. Their model could generate text more than 6 times faster than a traditional one. And this wasn't some minor tweak. This was a fundamental re-engineering of the AI's core engine.
To really understand their breakthrough, we have to pop the hood and look at the architecture that powers pretty much every large language model today, the transformer. And at its very heart is a single, brilliant concept.
All right, so large language models generate text one piece at a time, what we call a token. The absolute magic that lets the model understand context. Knowing that in the phrase, the red car, the word red is describing the car. That whole process is called attention.
Essentially, for every single word it processes, the model runs this tiny little search operation, and to do that, it assigns each word 3 distinct roles.
Think of it like this. First, you've got the query, which is like a token asking a question. Hey, what information do I need right now? Then you have the key, which is another token basically advertising what kind of information it holds. And finally, there's the value, which is the actual information the token is ready to share if its key matches a query.
So, the model compares every word's query with every other word's key to map out all these relationships. But just imagine trying to do that for a really long text, say the entire first Harry Potter book. Comparing every single word to every other single word, well, it creates this enormous computational traffic jam, which led to a clever but very problematic solution.
So the original fix for this compute problem was, you gotta admit, pretty brilliant. It's called KV caching. The idea is, instead of recalculating everything for each new token, the model just stores the past keys and values in memory.
This one trick turns an exponential compute problem into a much more manageable linear one. But in solving that one problem, it accidentally created a whole new monster, a massive, massive memory problem. Now the model has to hold on to the key and value for every single token it's ever seen, across dozens of layers. And that adds up fast.
For a large model, we could be talking about retrieving a staggering 400 gigabytes of data from memory for every single new word it generates. This right here is the memory bottleneck that was putting the brakes on AI development.
Now, people tried to shrink this cache with things like multi-query and grouped query attention, but they all forced this really difficult trade-off. Yeah, you could save memory by making different parts of the model share keys and values, but you lose performance because those parts couldn't specialize anymore.
So the AI world was basically stuck. You shrink the memory, you hurt performance. And this is exactly where DeepSeek's big breakthrough happens. Instead of just trying to make the old system smaller, they completely reimagined it.
They asked a totally different question. What if the model could learn to compress its own keys and values? What if it could create its own highly efficient secret shorthand for memory? So they introduced a new step. Instead of creating keys and values directly, the information is first squeezed through this compressed, shared representation, a latent space. This is the secret sauce. It's like a bottleneck by design, forcing the model to learn and store only the most critical, most important information. And from this highly compressed, latent space, each part of the model, each attention head, then generates its own unique keys and values. So you get the absolute best of both worlds, the flexibility of the original method, but with the incredible memory savings of a shared system.
And here's the kicker. Thanks to some really clever math, this whole extra compression step requires 0 additional computing power when the model is actually running. It's just a truly elegant solution with staggering results. With their new method, multi-head latent attention, the cache size is finally disconnected from the number of attention heads.
I mean, the results really do speak for themselves. A standard model needed over 4,000 kilobytes of cache for every token. The best compromise before this, grouped query attention, needed 500. MLA gets it done with just 70. It's just incredible. That 57x reduction isn't just a memory saving. It's a fundamental upgrade to the architecture that actually improves performance while drastically increasing speed.
They didn't just bend the rules, they broke the trade-off. They got a smaller cache, faster speed, and a better model, all at once.
You see, DeepSeek didn't just find a workaround. They evolved the transformer itself. They taught the machine how to be more efficient on its own terms. By rethinking a core component that everyone else just took for granted, they have blown the doors wide open for the future of AI. It proves that even the most fundamental rules are just waiting to be rewritten, and it really makes you wonder, what impossible trade-off will be broken next? If you liked the video, subscribe, leave a like, comment on what you liked most, and share the video.